The C language doesn't have a string data type. Instead, we use an array of the char data type. So in my program, I'm declaring what we would call a string in C, and I'm naming it string1. I'm also initializing it with the string Homer. Notice that string1 could contain up to 25 characters, but right now it contains 6. Here's why. An array looks something like this. Now remember, this is an array of chars. Notice something else. Each spot in the array has a number associated with it. This number could be referred to as a slot or an index. You'll hear it both ways. The capital H is in slot 0 or index 0. The lowercase o is in index 1. The lowercase m is in slot 2, and so on. The actual letters of Homer's name take up 5 slots. But then we have a 0 following the lowercase r, and that 0 is a marker for the end of the string. In other words, that's how C knows where the end of that string is. Because remember, the string could take up 25 of those spaces. We don't know what's in the rest of the array. It's just junk characters. So that's why I'm putting question marks there. Something else. The string could take up 25 characters, but the top slot number is 24. How come? The answer is because we start at slot 0. So every array in C has 0 as its first index, and the top slot number is 1 less than the amount of things the array could hold. That's going to take some getting used to. So let's go back and print out this string. To print a string, I'm going to use the S placeholder, not the C placeholder. So I'll press Ctrl F5 and we'll take a look. It prints out Homer, but it doesn't print the 0 at the end. Remember, the 0 is just a marker for the end of the string. It's not going to print out. String 1 can be referred to as an initialized string because I'm starting it off with a value contained in it. I've declared another string called string 2, and I'm not giving it any string to start off with, so it's an uninitialized string. If we look at a diagram of string 2, you can see that the slot numbers again start at 0 and go through 24. But now I've got question marks in all of the slots because we don't know what's contained there. Something's there, we just don't know what it is. It's just junk. So let's print these strings out. String 1 prints out just like it did before, but look what we get when string 2 prints out. What you're seeing on the screen are the junk characters that were in string 2. But if you count them, you'll get more than 25 of them. The reason is the printf function keeps printing a string until it gets to a 0 in memory. It took this many characters until it just happened to hit a 0 someplace. I've seen it take screenfuls of characters to get to a 0 when junk was printing out, so don't be too surprised if that happens to you. The next thing I'd like to talk about is how the fgets function lets you get string input. Scanf just doesn't do a really good job when it comes to getting string input, but fgets actually works pretty well. Here's how you use it. It's got 3 things inside the parentheses. Those things are called arguments in programming talk. The first one is where you want the string to be stored. So here I'm going to store what the user types in into string 3. The next argument is the maximum number of characters that you will allow the user to type in. Here it's 25 because that's how big the array was, and I sure don't want the user typing in more characters than the array can hold. The third argument is where the input is coming from, and standard in means the keyboard. So we'll run the program. It prompts for a string, and so we type in Bart and hit the enter key. Here's what that looks like in memory. We can see that there's an additional character besides just the letters of Bart and that terminating 0. We're also seeing an end of line marker, that's the \n, which is what we got from the enter key. It's important to remember that that \n becomes part of the string. Let's see how that \n affects things. In my code, after the user types in their value for string 3, I'm printing out string 3 and then string 1. I told printf to skip to the next line after printing out string 3, but here it skipped an extra line. That leaves a blank line in between the two strings of output. The reason it did that is because of the \n that's part of string 3. So in this case, I want to remove that \n. Actually, I can't remove it, but I can replace it with a terminating 0. Here's a diagram of what I want to do. We're looking at string 3 the way it's stored in memory. I know the length of string 3 is 5. That's BART and then the \n. That's 5 characters, followed by the terminating 0. I want to replace the \n with another terminating 0. So the length of string 3 is 5, and the slot where the \n is located is slot 4. That tells me if I know the length, I can calculate the slot where the \n is located. To replace the \n with a terminating 0 takes only one line of code. I use some color here in this line of code just to help you focus on the syntax. So I'm saying, in string 3, and then inside the brackets for the slot number, I want the length of string 3 minus 1. In that slot, I'm going to store a terminating 0. The \n is replaced by a terminating 0 the way it's shown in the diagram now. It doesn't matter that there was already a terminating 0 in slot 5. The 0 in slot 4 has become the new terminating 0. I'll add that to the code that we had before, and let's take a look at the results. Looking at the output, I can see that the extra end-of-line marker is no longer there. So there's no blank line between my output strings. To make use of the way the C language defines strings, there's a special library called string.h. One of the functions in that library was the string_len function that we've already used to determine the length of a string. Here's another one. I'm defining 3 strings in my program, and on line 12, I'm copying string 2 into string 1. So if you want one string to be the same as another one, here's how you do it. So now string 1 is an exact copy of string 2, and the word hop that was in string 1 gets replaced by the word skip. Let's print the results out. As shown in the console window, when I print out string 1, the word skip appears in the output. Let's try something similar using a string literal for the second argument to the string copy function. Here I'm telling the computer to store the phrase, "a literal works too," into string 1. So let's test it. The output shows us that we can use a literal for the second argument, but not the first. Remember that. I wonder what would happen if I tried to copy a string that was too long for string 1 to hold. When I run my program, this is what I get. My program crashes. It actually stored the string where I told it to, but it went past the boundaries of what string 1 could hold. So I get an error window, and when you get one of these, and you will, just click the abort button and then go back and figure out what went wrong. The C language string library lets me build strings by adding them together. This process is called concatenation, and the library function is called stringcat. Here I'm building a string, and in my code I start on line 12 by adding a comma and a space to the word hop that's already in string 1. Then on line 13, I'm adding another string, which is the word skip. I'm adding that to what's already contained in string 1. Line 14, I'm adding a comma and the word and to what's already contained in string 1. And then finally on line 15, I'm adding string 3, which contains the word jump. Now all of that's been added to string 1. Here's what we get when we print out string 1. Another function I can use is the size of function. It'll tell me how many slots are in my string arrays. On line 18, I'll print out the size of string 1. Here's the output. Then on line 19, I'll print out the length of string 1. Now realize that in this case, the length is different from the original size. That's because the contents of string 1, marked by that terminating 0, don't completely fill up the possible slots in string 1. Here's the output. The string library also lets me compare strings in the alphabetical sense. So here I'm declaring 4 strings, and I'll be using the string comp function to compare them. On line 13, I'm comparing string 3 to string 2 alphabetically, and the process will work just as if we humans were doing the same thing. That is, it compares the first 2 characters, they're the same. It compares the next 2 characters, the O's, and they're the same. It compares the next 2 characters, they're also the same. But when it compares the I in string 3 to the E in string 2, it knows that string 3 is alphabetically greater than string 2. What that means is it would come later on in the dictionary. The string comp function returns a number. So on line 13, notice I'm printing out a number. Because string 3 is alphabetically greater than string 2, line 13 will print a positive number. Let's see if it does. Yeah, it prints out a positive 1. Things like this are going to get more meaningful for you when we get to if statements. All right, now let's compare string 1 to string 2. Here, string 1 is alphabetically less than string 2, so line 13 will print a negative number, as shown here. As the last example of the string comp function, let's compare string 1 to string 4. Because they're identical, line 13 will print 0. You could remember this as thinking, well, there are 0 differences in those 2 strings. Here's a couple more examples. I just want to show you that you can compare a string literal to a string variable. Or even a string literal to another string literal. The last thing I'd like to point out is that we can access individual characters in a string simply by using the slot number where that character is located, and the slot number goes inside brackets. We did that earlier when we replaced the \n with the \0. So let's go back to the first string we talked about today. String 1 is initialized with the word Homer. Here's what it looks like in memory. Let's say I wanted to change the R to a Y. The R is in slot 4, so here's what I'd do. On line 10, my code says go to slot 4 in string 1 and store the character Y. Let's print that out and see if it worked. Yes, it did. So here's an example of physically changing the contents of a string. Later on, when we get to arrays of numbers, we're going to be doing similar things with them. As shown in this last little bit of code, I can also access a character in a string without changing it. On line 14, I'm going to print out the second character in string 1. Now what you have to remember is that the second character is really in slot 1. That's why I have a 1 inside the brackets on line 14. Here's the output. I hope this little video helps you understand some of the ways we can use strings. As always, if you have questions, please get with me.